Hello, everyone! Chapter 7, Learning Target 5. This is Miss Osier.
And Miss Lahar.
And here we go. Well, all that completing the square was actually purposeful.
Yep.
It's so we can write a quadratic equation in vertex form.
Mm-hmm.
So,
Let's do
it.
an example. So, we have y equals x squared, the normal, parent function of x squared graphed, and they want us to consider the quadratic x squared minus 8x plus 18. So, yep. So, using the method of completing square, write this equation in the form of that.
There should be a square there.
Son of a biscuit. Yes. All right, so we're going to complete the square, which does look a little bit different. Oh, we moved the y. Well, yeah, whatever.
You can do it multiple ways.
Mm-hmm.
I like to subtract the 18 and do it the way that you've been doing it, but other people also do it this way.
So we're just going to show you a different way this time. Just moving the constant term over a little bit.
So we're going to divide by 2 and square it. 8 divided by 2 is 4. 4 squared is 16. Now, remember, we're keeping it equal. So when you do it on the same side of the equation, you have to do a plus and a minus because that cancels out, and then it's still equal to what it was.
Okay. Again, you can move your constant term over like we have been doing. It's just that if you look at the vertex form, we're trying to get that k value because that's your y value of your vertex point. So anyway, whatever way works.
So now, the entire reason we did that is so we could say that 4, 2 is the vertex. So notice, 4 is negative here, but positive here. That's because it's inside the parentheses. If you remember from circle equations, if you remember from all sorts of things that we've done, when it's inside the parentheses, you change the sign. When it's outside, you keep the sign. So change, keep.
So that from that vertex form, I can pull out that the vertex is 4, 2. So how is that different from y equals x squared? Well, it goes right 4 and up 2.
It's a translation, people.
Oh, snap. So then you draw your graph, yada, 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 sketch the graph we did in vertex form. What are the vertex points?
Now, if you're wondering where all those other points came from, remember it was this original point, and all that changed was the vertex. This is still x squared. We just moved it.
Yep, right, 4 up 2.
Everything else is the same. Okay, and we did it. Yay.
Yay. What are the coordinates of the vertex? So this is the official, oh, I forgot the square again.
That's okay. It's squared. There's a squared right there. Okay. So remember, this sign will change. This sign is whatever it is. So change, keep.
Okay, the value A in front, and we'll get to this when we get to translating stuff, is a vertical stretch, and now we're going to do a few examples.
All right, so place each of the following quadratic functions in vertex form and identify the turning point. Turning point is the vertex. All right, so again, you can do multiple ways, but we still need to deal with that coefficient because that's not going to fly. So we're going to take the 3 out.
Oh, look, I did move the y.
So over here, we're doing it the way before. We moved the 2 over. And so now we have a blank on both sides. 4 divided by 2 is 2. 2 squared is 4. Whoa, why is that a 12?
Because remember, you took out a 3, so 3 times 4 is a 12 over there. You got to keep everything the same.
Okay. Don't you like how we anticipate your questions? We're good.
So on the left, you can simplify. Okay, and then you complete the square with the x squared plus 4x plus 4.
And then now, so that it's in the same form, because you're basically done, we're just going to move this 14 over so that it's on the same side.
Okay, so now, oh, I didn't show it.
So it would be 3x plus 2 squared minus 14. And then again, it's change, keep, so negative 2, and that would be a negative 14. Look at us go.
Vertex. Oh, that's the form.
There it is.
And that's vertex form. I think it pops out.
So
there's your vertex, and there's your vertex form.
Boom. All right, next one. We got to get rid of that 2, and we got to move the 1.
Okay.
So the 2 comes out, the 1 goes over, and we have 2 blanks.
Oh,
3 divided by 2.
3
it's
halves.
Okay, everybody. You're okay.
I don't know.
Everything's okay.
Oh, there
So
it is.
it's okay. We just got a few steps going in here. Okay. So 3 divided by 2 is 3 halves. 3 halves squared is 9/4. We have to add that to both sides, but remember it's 2 times this, which is 9 halves. That's what this is showing, that 2 times 9/4 is 9 halves. Your calculator can also do that for you.
Adding negative 1 and 9 halves, you get 7 halves. You would move that over, so it would be negative. So we would have, there's the vertex form right there. So then again, in the parentheses, it's going to be the opposite sign. So you have negative 3 halves, and then it is negative 7 halves.
Boom, there's your vertex.
All right, think back to algebra.
There we go.
You learned all about the axis of symmetry.
The axis of symmetry and how to find the vertex. So it's x equals negative b over 2a. You do need to know that. You will not be given it. It's a thing.
So we're just kind of using both ways to show you that they work. You can use whatever. Well, yeah. So here, this would be negative b over 2a. So you would get x equals
So
positive
negative 12 over 2 times 2.
So you get x equals 3, and then you would plug that into your expression to get your y value. So that's one way of getting your vertex.
So now I could easily write this equation, assuming that I don't have an a value, as x minus 3 squared minus 11.
But here is us completing the square just to make it look kosher.
Because that 2 matters, people. Okay.
So we took out a 2. Half of 6 is 3. 3 squared is 9. 2 times 9 is 18. So that went over there. And you see how it works.
Oops.
3 comma negative 11. We just want to remind you of the negative x over b, you know, just to drive it on home.
All right, let's do it again. Negative b over 2a. Boom, boom, boom.
X equals 10. You plug it
that bad boy in.
You get 5, so your vertex point is 10, 5. So now let's complete the square with a fraction, baby.
Woo! Okay, here we go. Take the negative a fourth out. When you divide 5, right, because when you factor, you're dividing. When you divide by 5 by a fourth, you're actually multiplying by 4. Because you're multiplying by the reciprocal.
Yep.
It's exciting stuff, I know.
If you didn't know that, use your calculator to do the fraction work.
Okay.
Half of negative 20 is negative 10. Negative 10 squared is 100.
100.
Negative 1/4 times 100, though, is negative 25. So that's what went over on the left side.
Boom.
Simplify, move the term over. Oops. And you would get the vertex at 10, positive 5.
Because the 5 would add over.
Yep.
Way to go, everybody. Have a wonderful day. We'll see you in class.